we started with yesterday. So we're going to use those calculator tricks that we learned to find missing pieces, all right? All right, now on some of these, they may already have it graphed for us, and we're just looking at the pictures. But it says on number 1, a rancher has 100 meters of fencing with which to build a rectangular corral. The graph below shows the relationship between the area and the length of the corral. Okay, so the first thing they ask us is what's the independent and dependent variable. So which one is usually our independent, X or Y? X. All right. And what's on our X-axis? Length. So our length is the independent variable. All right, meaning our dependent is our Y-axis, and what's on the Y-axis? Good. All right. So then the next thing they ask us to do is identify the x-intercepts. That means where it touches the what? The x-axis. Okay, so my x-axis is the one here on the bottom. How many times does it touch that line? 2. Where at?
0, 0.
Right. Okay, so this point is 0, 0 over here in the corner, right? All right, and this next one, I went over to 50, but did I go up or down any? No. So this one is at 50, 0. All right, then they ask where the vertex is. Well, first of all, is my vertex a maximum or a minimum in this picture? Maximum. Good. All right, so that means my vertex is this point right up here. All right, so to get to that point, we have to go over and up. How many over did we have to go? How many over? 25, okay. And how many up do we have to go? 600. So this point up here is at 25, 600. So just read the sides of your graph. All right. So now we have our vertex. Part D says, what does the ordered pair 10, 400 mean? So in an ordered pair, the first one, the first number represents what letter? X. And the second represents Y. Okay, and what did we say that our x-axis is labeled? What's on that one? Length. Okay, so that means when length is, they said it was 10, right? So 10 meters. And what did we say that our Y is named? Area. So when the length is 10 meters, the area must be, what number do they have plugged in for Y? Right. Is 400 meters squared. Good. All right. E says, how much area can be enclosed when the length of the corral is 45? So again, is length on my X or my Y-axis? X. Okay. So on my X-axis, I'm going to go over to 45. That's right here, right? I need to see where does that intersect my graph at. Yes, very good. So whenever my length is 45, what's the area going to be? 200. All right. Oh, is it 200 or is it 200?
It's 200.
It's right on. It's right above 200. It looks like one line above. So 225. Tiny line. It's hard to tell. Yeah. All right. So we've got the coordinate point 45, 225, which, like you guys said, really means that the area will be 225 meters squared. All right, and then F says, where do you look on the graph to find the greatest area that the rancher can enclose? So is area X or Y? Y. Okay, so I'm going to look on my Y-axis at the largest it gets in my picture. What's the highest Y in this picture?
625.
Right. Okay, so at 625, that's the most it can include. So my vertex is what gave me that answer. Okay, and it is at 625. 525. Did we put that? Oh, we had this one wrong too, didn't we? We didn't count the extra line. That should have been 625 there as well. All right, and then the last thing for this question says to find all of the possible dimensions of the corral if the area is 525 square meters, and then draw pictures of those. All right, so again, area is X or Y. Y, okay, and they said that Y or area is going to be 525. So on my picture, I'm going to go up to where 525 is. So that's one line above 500, right? Okay, so that would be this line here. So how many times does my graph touch that line? Twice. So apparently there's 2 times it could happen, right? Okay, once, right here, when X is what? 15, and another time right here when X is 35. All right, so our 2 options are at 15 and 35. So when it says, what are our possibilities? It could be at 15 when we get 525. The other option is we could be at 35 and 525, right? Okay, and they said to draw pictures of what this could look like. Okay, so my length runs long ways, right? Okay, so right here I'm saying my length is only 15. So my length, 15. That means my width is going to have to be pretty big, right? So this is where my width is going to be much longer, so that my area ends up being the 525.
So 35
35 times 15 would give me 525. My other scenario is where the length is 35, right? So now these sides are my 35s, and my width is the short side. So now the width would be the 15ths. And we still get that area of 525. All right? All right, we got one more picture to look at. So if you'll flip it over on the back, we're going to do the same thing. Look at the picture and answer the questions. All right. So on number 2, it says, Quinn, Gladys, and Bob went outside to launch model rockets. Each person in the group chooses one rocket to analyze. Answer the following questions for Bob's rocket. All right, so we're looking at a picture of Bob's rocket. First, they ask for the independent variable. What's my independent variable? Time. Right, good. Because remember, this is my x-axis. So what's my dependent variable? Height. Right, because this is on my y-axis. Good. Right. So what depends on what? Very good. Right, makes sense because how high the rocket is in the air depends on how much time or how many seconds has passed, right? Okay. All right, so then part C says, from what height was Bob's rocket launched? So launched is where it starts at, right? So how high off the ground did this thing start at? 10, yeah, right here. That's where it starts at. So it started at a height of 10, and this is in meters. So it starts at a height of 10 meters. Okay. They asked, when did Bob's rocket hit the ground? So it hits the ground when it lands all the way over here, right? Almost 4 whole seconds, yes. So just under 4 seconds. Okay. E says, when did Bob's rocket reach its greatest height? So the greatest height would be what we call the vertex, right? So that's up here. Is the height, yes. And how much time has passed? What time is, or how many seconds have passed at that point?
2.
Around 2. Maybe a little bit under 2, right? Because 2 is this line beside it, right here. So I'd say just under 2 seconds, or between 1.75 and 2 seconds. Either one is fine. So between 1.75 and 2 seconds. Or you could do kind of like we did here, just under 2 seconds. We're just approximating. Okay? All right, then they also asked for the greatest height. And somebody just told me what the greatest height was. What was it?
A little bit below 65, so like 68.
Yeah, right. Yeah, very good. So just over 65 meters, or an estimate number would work too. Just over 65 meters. All right, then they asked how many seconds was his rocket in the air? So how long was it off the ground for? From the time it started till the time it ended, right? So about how much time passed there? Right, 3.8, just under 4, somewhere in there would be a great estimate. Good. All right. H says, at what time is the rocket at a height of 25 meters? So now I'm going to go back up here to my graph and find 25 meters of height. So 25 meters is right here. That's right here, right? Right, it happens really early on, right? And then it happens again later on, right? So there's 2 times where it's going to be at a height of 25 meters. It does look like the first one, like he said, is really early on. A quarter of a second. Good.
And the second one is like 3.5.
Perfect. Those are great estimates. So that's exactly what we'll go with. So the first time at a quarter of a second, or 0.25. And then again at 3.5. All right. I says, for approximately how many seconds was it at 45 meters or higher? All right, so 45 meters is here, right? So it was at 45 meters or higher from here until here, right? So we need to figure out how much time passed between here and here. Okay, well, the first line I drew ends up about where? About how many seconds? Between 0.5 and 1, so about 0.75, okay. All right, and then the next one is at approximately 3 seconds. So if I'm trying to find the difference there, what are we going to do? Subtract, okay? So I'm going to do 3. I think that was one off on the key. I need to fix that. So I need to do my 3 seconds minus my 0.75 seconds. So approximately, what's that going to give us? If you have a key, you might want to make that little adjustment there. It's 2, not 1. All right. Now for the very last question, it says Bob's rocket scientist friend finds the actual equation to represent this parabola path that's drawn up here. It says that the equation is negative 16.2x squared plus 60.75x plus 10. Using your calculator, determine the rocket's exact maximum height. Round to the nearest 10. All right, so we're going to have to use our calculator. So remember yesterday we said the first thing we do is put the equation where? In y equals. Okay, so that's where we're going to start. I'm going to go to y equals and type in that equation that they just told us on the paper. So it's negative 16.2x squared plus 60.75x plus 10. Then we hit graph. All right, this is what we see, right? We can't probably see the whole thing. But we're supposed to be finding the maximum height. So I've got to see the height, right? Okay, so what are we thinking? We know approximately what the biggest height is, right? We said it was just over 65. So we need to make our graph go a little bit higher than 65, right? Okay, so to do that, you go to the button on your calculator that says window. So you see that second button on the top row that says window. Okay, so we don't really need to change our minimum values. If anything, we only need to see the real values. So you don't have to have negatives here. You could just start at 0. And this thing only goes to 4 seconds, right? So my biggest number I would need here would maybe be what, 5? So I can see just past it. Okay. All right, now arrow down to where it says Y minimum. Again, we're only looking at the real deal, so starting at 0. And you guys said we need to go a little bit higher than 65. So what do we think? 70? Perfect. All right, so now that we've changed our window to 0, 5, we left this as 1, 0, and 70. Let's hit graph again. And now we can see a better representation of the graph, right? So if you ever can't see what you want to see, just go to the window and change out the numbers. Okay, and we said we want to know that highest point. What do we call that highest point? A vertex. And is it a maximum or a minimum vertex? Maximum. Okay, so remember from yesterday, we pressed second trace. Like you guys said, I want a maximum, so that's number what? 4. Okay, and then it says left bound. So I arrow over onto the left side of that vertex. So I got to be somewhere over here, right? And I'm going to hit enter. Now it wants a right bound. So now I got to move back over there to the other side. And I'm going to press enter again. And then it says guess. So what do I do now? Enter one more time. Okay, and approximately what does it say for the Y value? What's the highest? 953, is that what it said? Yeah, okay. So it asked us to go to the nearest thousandths place, so remember that is 3 decimals. Okay, so like you guys said, that ends up being 66.953 meters. And if you forget how we came up with how to be able to see that, I'll make a quick note for you here. We just went to the window. We changed our X minimum to be 0 and our X maximum to be 5. We changed the Y minimum to be 0 and the Y maximum we changed to 7 so that we could see a better picture. All right. Okay. I will bring you guys